I'm Aditi Kinkhapala from New LJ Institute of Engineering and Technology. So let us start with the concept of Q, and in that we will see what is DQ and what in general are the applications of Q. So students, we have gone through what is Q, that is linear queue, circular queue and priority queue. So DQ is the next type of queue, which is also a variation in the queue. Now students, a DQ, sometimes also it is pronounced as deck or DQ. It is basically a list in which elements can be inserted and deleted at either end. Now we have seen that priority queue maintains the priority. Linear queue, basically only from rear we could insert and from the front we could delete. In circular queue, we could insert from rear, but it overcomes the drawback of linear array, that is memory wastage is less in circular queue because it points to the first index again, right? So, DQ is basically, it is one kind of queue only in which elements can be inserted or deleted at either end. Now, what it means by inserting and deleting at either end, that is we can insert and delete from both the pointers, that is front and rear. Now, if you can see here, this is the DQ data structure wherein inserting is possible at the front and removal is possible from the front. Similarly, insertion is possible at rear and removal is also possible from the rear. So it is basically also known as head-tail linked list because elements can be added to and removed from front. Front is also generally known as head, or the back, which is known as tail. Now, it should be noted that no elements can be deleted or added from the middle. So, it has to be from either the starting point or from the back, right? So, it could be from the front or back, that is from front or rear. Now, students, how it is stored in computer memory. So, in order to implement it, right? So, if we want to implement it, we can either use a circular array or a circular doubly linked list. So, we know students from circular queue, what is a circular array? So, it is basically a array in which we can insert element, and once it is, once the size is full, size of the array is full, it again points to the first position. In DQ, two pointers are maintained, left and right, which will point to the either end of the DQ. Now, elements in a DQ extend from left end to the right end, and since it is circular queue, if we say DQ n minus 1, so the last is followed again by DQ 0. So, if we consider this array representation, that is circular array representation, it starts with indexing 0 to 9. Right, so the first element currently is basically the third element. So left pointer is here and here is the right pointer. Now, if we insert two more elements, so it will be inserted here and here. And next, if we want to insert, so this DQ n minus 1, it is now followed with here. So it would be inserted over here and then 56. So this way we can keep on inserting and deleting elements, right? So here if we have deleted element, deleted, and again it goes on in form of a circular array. Now again students, there are two variants of a double-ended queue. So there are two types we can say. One is input restricted DQ and second one is output restricted DQ. Now, what do you mean by input restricted DQ is that it has some restrictions on the way we input. That is, in this kind of DQ structure, right? So, in this kind of double-ended queue, insertion can only be done at one of the ends, but it is free for deletions. Okay, so deletions can be done from both the ends, but insertion has to be done at any one of the ends. That's why it is called input restricted DQ. That is, for input, it is restricted that it could be done from only one end. Second one is output restricted DQ. Now, students, in this DQ, what will happen? Deletions can be done only at one end, like one of the ends, while insertion can be done at both the ends. So, in this type of DQ, restriction is on the output, right? So, basically deletions. So deletions can be done only at one end, while insertions can be done at both the ends. So input restricted deals with insertions, restriction on insertion, and output restricted deals with uh, deletions. Output restriction deals with deletions. That is, it is deletion is restricted and insertion is done at both the ends. Now students, what are different operations which we can perform on DQ? So first, as we know that we can insert from front, so it could be, we can insert from front and rear, and we can also insert, delete from front and rear, right? So we can insert from front or delete from end, or insert at rear and delete from rear. Also, if we want the current element, we can get the front and rear element, right? So we can say Q of front, or we can say DQ of front will give us wherever the front is pointing. In here also we need to check two conditions. So we can say though there are two more operations, which are, we need to check whether the DQ is full. So we can create a function which returns a true if the stack is full, otherwise it returns a false value. Similarly, the second operation, we have to check in case of deletion specifically that whether the queue is empty or not, right? So we need to check for the front and rear pointers and the indexing of it, right? So if a function returns true value, that means the stack is empty. Otherwise, it will return the false value. So we need to, again, if while implementing this, we need to check for the pointer values in order to check whether the DQ is full or not. Now students, DQ can be used as a stack. Now how DQ can be used as a stack? We know we can insert from front and delete from front, and insert on the rear end and delete from the rear end. So students, if you can just see only this part, if we just consider this part, right? Insertion and deletion from one way. So if we ignore this insertion and deletion, and if it is only, if we consider only insertion and deletion from one end, we know that in stack, we can only insert and delete. For Q, if we just keep this insertion from the rear and deletion, insertion from the rear and deletion from front, this is nothing but this is the same DQ which can be worked as a Q, because in Q we have insertions from the front and deletions from the rear part. Be used as a palindrome checker, right? Means that if we read the string from both ends, it would be the same, right? So if we start reading from here and if we start reading from here, it would be the same. So DQ can also be used as a palindrome checker. Again, it can be used in multiple scheduling, right? So if we have two processors, P1 and P2, so these processor in they have their own DQs, right? So they have their own DQs, and in here there are processes or threads which they execute, right? So if the process they have to execute comes over here, it gets inserted from rear and gets deleted from the front, right? Similarly, P2, so this processor P2 also, if the processes are executed, it gets deleted, right? So after certain moment of time, if this processor has more number of processes, so this front can help the, if this DQ can help this P1 processor to shift the other processes to P2, right, for the load balancing. So it is also used in multiprocessor and for scheduling purpose as well. Now students, let us see the general purpose of applications of the queue. So what are the, in general, what are the different applications of queue? Now we have already gone through the entire chapter, and now we know that queues basically are for first in, first out. They generally follow first in, first out procedure. Now where they are used, so they are widely used as waiting list. Whenever we work in a situation where we have a single shared resource like printer, disk or CPU, we have, the queue data structure is very useful for implementing those kind of applications. Now queues are also used to transfer data asynchronously. Asynchronous means data does not, the transfer and the receiving is not at basically same rate. Okay, so if there are two processes or two buffers like file input output socket, right, and if we need to transfer the data asynchronously, queue is helpful. Also, it is used in applications which need buffers. Now, where do we use buffers? So you must have observed when you play a song, right, or you play a playlist, what happens is first a song on the list is played first and then next and so on. So it maintains a buffer. So MP3 players, portable CD players, iPod, right? So playlist maintains buffer. So all the applications which require buffers, basically queues are used. It is also used for playlist for jukebox to add songs to the end and play from the first. So this is nothing but again a process of playlist, right? So that is again a buffer. Now students, it can be also used in OS for handling interrupts, right? So when we are working on a laptop, right, that is a real-time system. What happens if I click, if I do a mouse click, right? So as soon as if the process is going on and if I have clicked on a mouse, what will happen? First of all, it will be handled. So the button would be clicked and whatever, if I am clicking on pause, the video will get paused, right? So when programming in a real-time system, the real-time system can be interrupted by lot many things. Now, how to handle that interrupts? So operating system takes care of how to handle those interrupts. For example, a single mouse click can also be considered as a interrupt, right? So by a single mouse click, it is necessary for operating system, it is necessary to process these interrupts immediately before proceeding with the current job. So if this video is going on and if I play and if I give a pause button, so first of all it is an interrupt, it will be handled first, right? And then after if I play it again, then it will be resumed, right? So if the interrupts have to be handled in the order of arrival, then FIFO queue is the appropriate data structure for it, right? So students, in this topic, we have gone through different kind of queues. We have seen what are queues, what are the algorithms for queue, how to insert data in the queue, how to delete the data, how queues can be implemented, which data structure is used to implement queues, and what are the different type of queues. That is, we have gone through what is circular queue, priority queue, and double-ended queue, right? And we have also seen the applications of queue in this topic.